The first design pattern that we'll look at is the Singleton design pattern. If you don't have any of those books that I mentioned in previous videos, you can definitely take a look at the Wikipedia site for Singleton. It has quite a bit of information, including UML diagrams that we will get into. It's a pretty simple pattern. It only has one class. So it has a class. This class is called Singleton. It's got one data member called instance, which is initialized to null, and then two methods. One is a getInstance method and a constructor, which, as you can see over here, is private, which is one of the few situations where you will have to make a constructor private. Okay. So let's take a look at Singleton. The whole idea of Singleton is that you only want one instance of this class. You don't want more than one instance, exactly one, within the context of a running program. Okay, so what that means is a singleton is an object that cannot be instantiated by, that's not under the control of the developers of a program. A singleton can be created, but it cannot be instantiated. Right, so you cannot create instances of singleton because the singleton class itself has control over how it is created. So in this case we're talking Java, although you can set it up for any language. The idea is that by restricting the creation of a singleton to, in this case, the Java virtual machine, and by preventing direct instantiation, we can ensure that a second copy cannot be created. There can only be one instance of a singleton within a single running program, of course. Of course, you can start up many different instances of the whole program, and of course, yeah, in that case, each instance will only be limited to one singleton object. Okay, rationale for singleton. This is useful to prevent code from making maybe multiple copies of objects. For example, a deck of 52 cards. You don't want to have two ace of diamonds, or two king of diamonds, or king of hearts, or queen of spades, whatever. You only want one of each. Creating a new card object and using it could result in bugs, or there might be something else going on. So this is a common design pattern and is expressed. This is a common design problem and is expressed as a general pattern, that's singleton pattern, and it can be implemented in most languages. Every language is a tiny bit different. Java, you'll see that there's a bunch more things that we can do than was shown in the C# example that we looked at. Okay, so how do you prevent direct instantiation by developers of a client class? So objects are instantiated using the new keyword in Java, and new allows you to create a new instance of an object with the option to specify arguments to the constructor. Constructors have access modifiers like public, protected, private, package private, and that allows control of which classes have access to any given constructor. To prevent direct instantiation, you create a private default constructor so that other classes cannot create a new instance. So by making a constructor private, what you're doing is making sure that other client classes cannot somehow call the constructor. So you're controlling access to the constructor. So you start with a default constructor that is marked as private, so that's different. In the class definition, once again, why are we doing this? Just so that we can control who calls the constructor and therefore who creates the singleton object. Okay, so if you set up a class like this, even if it's public and you make the constructor private, as written, there is no way to use this class. Nobody can create an instance of this. This is just a class that sits by itself. You can never create an instance of singleton. So we want to prevent direct instantiation, but we do need a way to get a reference to an instance of the singleton object. So we still need to be able to create one instance of this class, and also return a reference to that this instance to whoever wants to use it. So you want to be able to use this class, but at the same time you want to control how it's created. Okay, so how do you do that? You need an accessor method, that's a get method, which returns an instance or returns a reference to an instance of the Singleton object class, but does not allow more than one copy to be accessed. So how do you do this? So way to do this is you set up a public static method called getObject or getInstance and store a copy of the Singleton in a private member variable. So first of all, you need a private, and you have to make this static so that what you're saying is there's one reference to the Singleton object class, and that is static. If you no matter you can only create one instance of this class anyway, but if by chance you somehow are able to create two, well, the reference to the Singleton object is still static, so all objects will see the same reference pointer. And how do you get to this? You set up a getter method, and here's the thing, if you ignore the if statement, this thing will return a reference to the static reference object. Okay, so here's our private constructor. It makes sure that no other client class can access this Singleton constructor. Only methods in the Singleton class can access this constructor. Well, how do you access this? Where do you access the Singleton object constructor? It's right here. If ref is equal to null, and it will be null initially. Remember that all data members in Java are initialized to default values. In this case, you have a reference variable, and because it's a pointer to a Singleton object, that will be initialized to null. And so initially there is no object. You just have this static variable which you can access internally. And then when some other client class calls the getObject method, it's a static method, and you don't need a Singleton object to actually call this getObject method. Remember, like methods like math dot square root, you don't need a math object to create or to call the square root function. You just call math.square root. Same way you can call Singleton object dot get object. What this will do is it will check initially ref is null, and so it'll create a Singleton object right here, and this should be the only place that you can create a Singleton object. Okay, so this is the only place you can call the constructor because the constructor is private. And so now the first time that you call getObject, ref will be null. You'll create a new object and have ref point to it, and then you return this. If you try to call this again to somehow try to create another object, well, ref won't be null. The static variable is seen by all instances of Singleton, and so this ref won't be null, and so you just return the current value of ref. Okay, so I'm going through it in a lot of detail, but I'm hoping this makes sense. What you've done with this method, by making it private, making the constructor private, you're making sure that there's only one way to access the Singleton object constructor, and you make a reference to the same kind of object, Singleton object, as the class that you're in, and make it static, so that this static method getObject can access it and create a new instance of a Singleton object and then return it. Hopefully, by putting in this if statement, there's only one time that you create the Singleton object. Okay, so you want to try this out. I think probably by trying it out in Java is probably the best way you can test out, and make sure that there's only one way to create the Singleton object. Okay, So that is the basic idea. And now what we'll do is we'll take a look at how to use this and also put in some additional safeguards to make sure there's only one Singleton object when you run a program that has this class. Okay, the initial call to get object method creates a Singleton instance, assigns it to a member variable, that's ref, and returns the Singleton. All subsequent calls will return the same reference pointer. So the first time you call getObject is when you create it. After that, you're just getting this pointer or reference data type variable. You could extend the functionality of the Singleton object by adding new methods to perform the types of tasks of your Singleton needs. For example, if it's a card or a deck of cards or something else that you only have to have one of, like a queue or something like that, then you need all those other methods. But this is what makes these methods and this data member is what makes sure that there's only one instance. Okay, so now what about multi-threading? Multiple threads calling the get object could cause problems. So what we're saying is if there's two threads that call this get object method, well, it is possible maybe just if one thread executes this, ref checks if ref equals null, and it is null. Let's say then another thread executes the exact same if statement right then, ref is equal to null. It also goes into the next statement. So we have two threads possibly executing this and creating two instances of the Singleton object. That is possible technically. It's unlikely, but it's possible. So multiple threads calling this getObject method could cause problems. So if one thread enters the method after another, a Singleton object constructor could be called twice. That's a problem. How can we fix this? We use the synchronized modifier to prevent two threads from calling getObject at the same time. Once you do this, that is all you have to do is add the synchronized modifier to the getObject method, and now only one thread will be able to execute this method at a time. Okay, the other thing that you want to worry about is the clone method from Clonable. So we can still clone a Singleton. That is, we might be able to say in some client class called test, and let's say you have set up a main method, and we create a Singleton object, and then we do this. We say .clone, whatever this object is, x.clone, and now we have a complete copy of the Singleton. We don't want that to happen. So remember that the Java-Lang object clone method is protected, but if Singleton object extends a class that does allow cloning, then it becomes a problem. To prevent an inherited clone method from being used, add a clone method of our own and throw the clone not supported exception. What does that mean? Just override the clone method, make it public. So remember that in Java-Lang object, clone is protected. Make it public and it doesn't do anything. Now you've overridden it and it just throws this. It says throw new clone not supported exception. That's it. And you have a throws clause in there because you are throwing an exception. Okay, so now we've blocked off another possible security hole, that is we don't allow clone to work. Okay, so to sum up, a Singleton is a class that can be instantiated only once. Implementing a Singleton class involves preventing access to all constructors. You make the constructor private. Provide a synchronized static method to get a single instance. Making it synchronized blocks off any problems with threading, multi-threading. And finally, we prevent cloning by overriding the clone method to just throw an exception. Okay, so that's it for Singleton, and next we'll take a look at how to do this, how to draw a UML diagram for Singleton.